Okay guys, back for number 5. You can read it, but essentially Brandon and Chloe are riding their bike in one direction along a flat straight road, or not in one direction, sorry. And this is Brandon's velocity in miles per hour, and this is Chloe's velocity also in miles per hour. So it says how many miles did Chloe travel from 0 to 2? If we want the amount of miles Chloe traveled, then we need to take the integral. That's how we go from miles per hour back to miles. This function, as long as we're positive time, can only be positive, so I don't have to worry about absolute valuing it. Okay, so obviously to get this thing, I need this, so I'll start there. If I take the derivative of this, though, the chain rule is going to be a negative 2t, and I don't want the negative 2, so I'll put a negative 1/2 in front of there. I'll go from 0 to 2. So I'm going to factor the negative 1/2 out. If I plug a 2 in, I get e to the 0. If I plug a 0 in, I get e to the 4th. So this is negative 1/2 times 1 minus e to the 4th. So if I distribute a negative 1/2, I get, actually I'll probably just leave it there. If I did distribute it, I'd get 1/2 e to the 4th minus 1/2. So either one of those answers would be fine. Next it says is, at time 3, is Chloe's speed increasing or decreasing? If we are asked this question, we've seen this a few times. Basically, if velocity and acceleration have the same sign, speed is increasing. If velocity and acceleration have opposite signs, speed is decreasing. You might remember me walking in a direction and acting like the wind was the acceleration. The wind's blowing in my face, I'm going to slow down. If the wind's blowing with me, I'm going to speed up. So we need to calculate C of 3. So if we did that, we would get 12 minus 3 times 3 minus 3 squared. So I get 12 minus 9 equals negative 6. So Chloe's velocity is negative. And then acceleration, I would have to take the derivative of this function, which is a product rule. So I'll go 1 times e to the 4 minus t squared plus t times e to the 4 minus t squared times negative 2t. So if I simplify that a little bit, I'm going to go ahead and factor the e to the 4 minus 2t squared out, and I get 1. And then I would get minus 2t squared. So this would be c prime of 3. If I plug a 3 into there, so I get e to the negative 5, which that doesn't matter, that's always going to be positive, so it's all right here. If I plug a 3 in, I get 1 minus 18, which is negative, so I get that c prime of 3 is negative. So since they're both negative, speed is increasing. I would say speed is increasing because velocity and acceleration have the same sign. So next page. So is there a time when Brandon's acceleration is equal to 2.5 miles per hour on the interval from 0 to 4? Okay, so this is a mean value theorem problem. So acceleration is the slope of velocity. So on 0 to 4, the slope here is 11 minus 1 over 4 minus 0. So the average, so Brandon's average velocity, or sorry, not average velocity, average acceleration. So the average slope of the velocity is 2.5. So as long as this was a differentiable equation, yep, and it says it was, then there will have to be a time when his instantaneous acceleration is equal to that average acceleration by mean value theorem. Okay. Part D, is there a time 0 to 2 which Brandon's velocity is equal to Chloe's velocity? I thought about this for a long time, and the only way I could figure to do this is to show that they had to cross somewhere by calculating their starting velocity. So if I took b of 0 and subtracted c of 0, and then if I took b of 2 and subtracted c of 2. So b of 0 is 1, and b of 2 is 1.5, and then c of x equals t e to the 4 minus t squared. So if I plug a 0 into there, I get out a 0. So if I, at the start, if I take Brandon's velocity minus Chloe's velocity, I get a value of 1. And then c of 2, if I plugged a 2 into there, I would get 2 times e to the 0, which would be 2. So I look here, and since At the start, essentially the B function is above the C function, and at the end, the B function is below the C function. I figure they got to cross at least one time. Like I said, super tricky problem. Lots of stuff that stumped me here. I had to look at the answer key for a part of it. So definitely a very tough problem. All right, guys, thanks.